So if we want to plot a regression line in Python, there's various ways. What I'll show you is kind of the slow and hard way, but a way where you can actually understand a few interesting things. So when we plot a linear regression line, we need X and Y data. Yeah. So we basically want, if we want to plot a line, we need the X and the Y points of that line. Just we had X and Y points here, right? So in order to get the X points, what we do is we just take the minimum of X of our data set and the maximum of X, because we want our line to be approximately from here to here. And then we use something called linspace. Linspace basically plots us equidistant, an equidistant set of numbers. So if you have, say, between -5 and +5, you say linspace -5, 5, and then you say how many points you want. So let's say 100. So you get exactly 100 points between -5 and 5. Yeah. So you see in a moment how this looks. XX equals np dot linspace. Yeah. And then what we do is, because we've got X here, right? We can go min X. So we just got the minimum of X to the maximum of X.
Mm-hmm.
And let's say we plot 200 points between the minimum and the maximum. Okay. So if we run this, so we just get this again. And then if we go XX, so this is just our X points for our regression. See, we get this between -3 and 3.8 or something like that. Yeah. Now, next, we need to produce our Y points for our linear regression line. So I call it YY. Yeah. And then what we do is we use the reverse of the polyfit function for that. So what we do now is we use another function called polyval. We plug in our M and our XX, and it spits out the YY values. We could also do it another way. We could just basically say M of 0. Actually, we could just do that. That's even more like maths. Times XX, yeah, plus M of 1. So this is just our equation for a normal straight line. Yeah. So when we do this and we go YY, we're basically getting another set of numbers here. Yeah. So now all we have to do is plot this whole thing. So we go plt.plot xx, yy. And here's our linear regression. So don't be deceived. Sometimes, you see, it looks like these points here, they go like this way, and the line doesn't quite fit the points. But that's only because these outside points here, they look like the inside points really, or the density of them determines the regression slope. And the outside points, they somehow produce an imaginary boundary, but that doesn't mean that the actual slope is like this.
Mm-hmm.
As you can see, the slope is actually a lot less than that. And so sometimes it looks like the line doesn't quite fit our data, but that's more a visual thing. And so it's not really based on the actual data set. So the actual linear regression is really, this straight line. Does it make sense to you?
I mean, I would say yes. Like the only thing that I would be curious now is like, because you said the YY, we could just like kind of switch around like our polyfit function into the polyval.
Yeah. Okay,
How
yeah.
that would look like.
Let me do this. It's even easier. It's called np.polyval. Yeah. M, comma. And what's next?
XX.
That's it. XX. Perfect. So let's run this again. Same thing. So we basically get, this is the regression slope of our autocorrelated x values and our lagged x values. This is how they correlate. Oh, and think about it, it's actually the returns. So it's the returns of x and the returns of lagged x. And this is the correlation between them.